Very good morning all my dear students. Today we shall discuss a unique problem in solids, that is tetrahedron. So this is a tetrahedron. We all know tetra means 4, hedron means faces. This tetrahedron is made up of 4 equilateral triangles. So this is the model which is made up of 4 equilateral triangles. Proceeding further with the problem, we can clearly see that in the given problem it is given the solid is resting with one of its sides. So taking right side as a reference, I have drawn one equilateral triangle. Next, by drawing this medians, we have identified the center, and from all the corners we have joined to this center to get its top view. Next, from this we have projected to get the front view. The unique feature of this solid is the height will not be given. How do I identify the height of a tetrahedron? Identify one edge from the top view which should be parallel to the xy line. So from this it is clear that A to O, which is parallel to xy line, come to corresponding corner, go to the front view. From here, for a given side, say 40, you should cut an arc to an axis to get its height. Proceeding further, as I told, from this point, cut an arc for 40 and join to get its front view. Next, in the question you can make a note that the base is inclined at an angle 30 degree. This is a unique problem wherein the base is inclined. Take one convenient point. So name this B dash of C dash. Now you need to draw one line. This part should be inclined at an angle 30 degree. Next, it's quite simple. From B dash measure O1 dash and measure A dash. Further mark or measure from B dash to O dash and again from A dash to O dash. Cut arc accordingly and complete this position. After completing this front view, what I have done, just projected from the respective points, and again from this side I have projected to the right side and I have named A, B, C, O, O1 accordingly. The next talk is quite simple. Just draw the boundaries with a darker line and check from the top view which are the sides are visible. We shall proceed. I have highlighted the boundary with a darker line. Next, from the top view, O to A is clearly visible. So draw this with a continuous line, and B dash of C dash is not visible. So you can draw this with a dotted line. Proceeding further with a third condition, what I have done here is I have drawn a line for a given angle, that is 45 degree. Here the resting side is inclined at an angle 45 degree. Which is the resting side? The reference one is BC. Here this is the one. The same resting side BC I have drawn here. So retain the same, it's supposed to be in the dotted line. Next, from this center, draw a perpendicular line, measure from this point to O, mark accordingly, again from this point to O1 and again A. After marking this, join this and make a replica of this figure somewhere here. After completing this position, what I have done, I have just projected from this to the upside and this to the right side just to get the final position. So here, after projecting, I have met the points A dash, B dash and points accordingly. We all know the final position, in the solid, the outer boundary should be dark. So it's quite simple. Join this with a continuous line and again this one continuous line. Again this, it is a continuous, and again this is a continuous. And coming to this axis, OO1 supposed to be an axis line. From this front view, you can clearly see that BO is clearly visible. So make this continuous line, and CA is not visible. So draw this with a dotted line. So this completes your tetrahedron problem. Thank you.